Welcome to Spring LIB.
Hi there. Today we're going to be talking about two different pendulums. One of these pendulums, TA, is a simple pendulum. It's a mass where the mass is in a very small space. It has a length of L and a mass of M. We've got a similar pendulum, pendulum B. Pendulum B has the same length, from the pivot point to the center of mass, and the same mass, but it's an extended body. So the main focus of this problem is telling the difference between a simple pendulum and an extended body physical pendulum. So what we're going to do first is just look at the period of the simple pendulum. So we're going to have TA is going to be equal to 2 pi times the square root of L over G. And that's just a really simple expression for the period of a simple pendulum. For pendulum B, we're going to have to use the equation for a physical pendulum's period. So we're going to have TB is going to be equal to 2 pi times the square root of I divided by M times G times D. So I here is going to be the moment of inertia for the whole pendulum, and D is going to be the distance from the pivot to the center of mass, which is L in this case. So we can just write down D equals L, and then we're going to figure out the moment of inertia as well. So I is going to equal the moment of inertia just for a sphere is 2/5 times M times R squared. But because this isn't just a sphere, because it's a pendulum, we've got to add in the parallel axis component. So we've got to add in the distance from the center of motion. So that's going to be plus the mass times L squared. Cool. From this diagram, we can also tell that R is going to be equal to L over 2. So now if we just take these two, all of this information, we plug it into TB, and we'll see what we get. So TB is going to be equal to 2 pi times the square root of 2/5 of M times L squared over 4 plus the mass times L squared. And all of this is going to be divided by the mass times G times L. After some simple cancellation, we can see that TB is going to be equal to 2 pi times the square root of 11 divided by 10 times L over G, which is nice because this is in real simple terms that we have for TA. So when we kind of put them together, we can see that TB is going to equal TA times the square root of 11 over 10. So that's really how you go about figuring out the periods of these pendulums. As you can see, pendulum B is going to have a higher period than pendulum A because it's pendulum A times a larger than 1 fraction. I hope that helped.